So there's basically three more basic functions that we should take a look at. I believe two of them are familiar, we've done them before, and one is brand new, right? It's totally brand new to Section 3.4, and we need to take a look at it. F of x equals the absolute value of x. If you recall, this is a classic case where we have a nice V shape, but let's do some point plotting. Let's look at some nice data on there, and again, I'll plug in some nice values from -2 to 2. So the absolute value of -2 is 2, right? The absolute value of -1 is 1, right? The absolute value of 0 is 0. The absolute value of 1 is 1, and the absolute value of 2 is 2. Many more points. We can point plot them, but let's plot the ones we have. So we have -2, 2. We have -1, 1. We have 0, 0, 1, 1, and 2, 2. So essentially, we behave like a line in that direction, and we behave a line in that direction, and what you have is that natural V shape, right, of a absolute value graph. So that's a classic condition of a absolute value graph. It has some sort of V shape, and there's what a basic absolute value graph, some basic points on that value. Letter H. The name we give this one is called the reciprocal function. That's the name we give it. We already see we have a problem because x cannot be equal to 0. And so when we go plot this, we're going to have what is famously known as a vertical asymptote. We've seen that before. The graph's going to be ripping itself apart to the left and to the right. So we basically need to figure out, what does this graph look like, right, when we're negative? And what does this graph look like when we're positive? So let's handle the negatives first. So if I put in a -1, right, 1 over -1 is -1. So there's one of my data points. If I let x equal -2, right, 1 over a -2 is -1/2. And if I let x equal to -3, we're going to get -1/3. A little tougher is what if I start letting it equal fractions, like -1/2. Well, if I put this in here, let me do it this way, right? We've learned that to take 1 and divide it by -1/2 is the same thing as multiplying it by its reciprocal. So we end up with -2. Same thing with -1/3. We'll end up at -3, and so forth and so forth and so on. So I have a lot of data to represent here. So we have -1, -1. We've got -2.5. We've got -3 and about 1/3. Half is -2, and 1/3 is -3. So you can see the graph is basically, right, going down to -infinity in this direction, and in this direction it's getting closer and closer to the x-axis. So there's basically our behavior of the reciprocal function when x is less than 0. But what if x is greater than 0? Well, same thing. If I let x equal 1, 1 over 1 is 1. If I let it equal to 2, 1 over 2 is 1/2. If I let it equal to 3, 1 over 3 is what we get. And then if we throw some fractions in there, right, if I put 1/2, we multiply by the reciprocal, we get 2. If I put 1/3, we multiply by the reciprocal, we get 3. So on this side, we have 1, 1 on the graph, we have 2 and 1/2, we have 3 and 1/3, I have 1/2 and 2, I have 1/3 and 3. So the graph is basically going to positive infinity to this direction, and it's getting close to the x-axis in that direction. So there is your classic 1 over x reciprocal function shape. Okay, and then some major points that are involved on that. And again, I would highly encourage you to probably do this on your own so you get more and more intimate, if you would. Familiar with, all right, what these graphs look like, and you can manipulate them easily. All right, so that leads us to the newest basic function of them all. We've seen everything else at some point or another, but what is this? This is what we call the greatest integer function. Okay, so the greatest integer function, and the way we work with this, let me come up with a decimal value. So what if I'm looking for the greatest integer of 1.33? Well, for that value, the greatest integer that's involved in this is 1. All right, even if I look for the greatest integer of 1.77, fight the tendency to round up, right? We're talking about what is the greatest integer involved in that particular number. Well, again, it's 1. The greatest integer of 1 is 1. The greatest integer of 1.99 is 1. And then once we turn to 2, we're now equal to 2. So with that point plotted data, right, the greatest integer, sorry about that, right, when I put a 1 in there, I get 1. And we're basically equal to 1 throughout that whole stretch. But then as soon as we get to 2, right, we can get as close as I want to 2, but we're up here. And then it's basically going to repeat that pattern. It's going to constantly be 2 until I reach 3. And then it's going to constantly be 3 until I reach 4. And then it's going to constantly be 4 until I reach 4. And then it's going to be constantly 5 until I reach 6. So you can kind of see what's happening. If we were 0, right, we're equal to 0 until we reach 1. We're equal to negative 1 until we reach, right, 0. We're equal to negative 2 until we reach negative 1. So we basically call this, another name for it is that we call a step function, because it looks like we're going up some little steps. But the greatest integer for any number between negative 2 and up to negative 1 is negative 2. Once I get to negative 1, my greatest integer is now negative 1. Once I'm in the stretch here, my greatest integer is 0. Here it's 1. And you'll notice I haven't lost the fact that it's a function, because if we were to draw a vertical line, let's say at x equals 5, right, this is open and that's closed. So the greatest integer of 5 is 5. One thing in, one thing out. And that is basically what that looks like. So I believe that is a new function in this homework set. That's how we work with it. It can get a little more complicated than that, but it's basically greatest integer function, or what we famously know as a step function. So that should wrap up section 3.4. All our basic functions, right? The easy ones, right? The tougher ones. And what we're going to now start to do is use all this to do some transformation work in the next section. So I'll see you guys then. If you have questions, you better ask. Jump on Canvas, ask your questions there. Hit me up with an email. Come see me during office hours. Whatever it takes to help you gain a full understanding of piecewise functions and these crazy basic functions. See you guys later.